Hello everyone, welcome to this episode of Reinventing the Wheel. I'm Aidloy and today we are going to reinvent rendering text. And why? You may ask why would I do such a mad thing? And the answer is simple. Back when I started creating CQUI, I already realized that rendering text is something that Bevy lets you do, but you don't have the necessary information to create a text input. Or, well, not always. It's a bit of a stretch to say that you have it, and then the text solution, the Bevy original text solution, wasn't really great beyond just rendering simple text. Today they have upstreamed an integration to Cosmic Text, which does a better job at rendering it. But still, I wasn't satisfied with it, and I'm just stubborn as a mule. So I decided to create a rendering solution and all the necessary parts to manage text, not as part of CQUI, but it's going to be a separate crate, but it will be integrated into CQUI, and it will be part of the text input, the text rendering, and anything that's related to text. At least that's the idea. But let me talk about a bit on the steps necessary to do that. And the very first thing I would like to point out is that I have taken a great inspiration from a coding adventure that I have linked down in the description, and I encourage you to watch it because it better explains explains it in a more entertaining way how you render text or what's the steps you need to do. And if you have watched that video, you would already know that Sebastian in that video starts by parsing the TTF file. And I just, skipped that entirely because there are already libraries that do that. And the library I picked to do that is actually the same that Cosmic Text is using under the hood, which is called Scrifa. And it's something that's managed by Google. And according to their documentation in the code, there are some gaps in the library that's missing. But honestly, I haven't encountered any of that missing functionality so far. And I'm happy to say that it allowed me to get the font data and the glyph data for regular fonts, variable fonts, and color fonts. So drawing emojis is now, well, not yet, but it will be possible because they are practically just regular glyphs with data on their color and how to blend them. So it's not terribly difficult to work with them. So for starters, I built the necessary foundation to grab the font data, and I have a little thing that I called a text node, and you probably don't see anything of that. So let me just make this a bit bigger. I made a text node that will take a handle for a given font, take a character, and the size it should be rendering at. Now, the idea behind all of this crate is, as I mentioned, to render text and to manage text. And the first step is what the Scrifa library does for me, so I don't have to parse TTF things. And the next step is rendering it, just so I can see what I'm doing. And the third is to make management and layout easier. I'm not there yet, of course. I'm currently at, let's say, wrapping up rendering, and I will show you where that is and how it looks like. So for starters, this font size and everything and what you see here probably will not stay as is or will be hidden under the hood somewhere. This is just an easy way to get into the drawing functionality. And if you look at more on that thing, it's let's say 1,000 lines of code to prepare the font data and to send it to the GPU for rendering. The only thing that I'm doing as a pre-processing to all of this is creating a mask. And this is a tip I got from the author of the, let's say, the Pathfinder rasterizer. It's him, Patrick Walton. He gave me the tip that it's a good pre-optimization to create a mask for your text before you even start to render it on the GPU, because 16 by 16 mask that you can see, for instance, here, can tell the GPU where it has to work and where it does not have to work. Basically, it's a three-state mask. One where the GPU absolutely has no reason to render anything because there is no text there. One state where it absolutely has to render a color, and then the transition zone. And this is where the GPU actually has to calculate the proper coverage of the font. So this reduces the amount of work significantly for the GPU side. And as you can see, I am logging here a couple of characters because I have just been wrapping up fixing evil artifacts during the rasterization. If I were to show you how it looks like right now, you will see that, or not. I'm not sure how much the compression will actually keep from this, but the point is, let me just take a screenshot and enlarge it for you so you can actually see what's going on. Up. So this is the rendered thing, and you can see the evil artifacts here, the little glitches that are appearing where certain lines meet. And this is something that I have ironed out on the CPU side, but I did not transfer the code over to the shader yet. It's not much work to do that, but I have to pay attention to synchronize it correctly, and then have to run some tests to make sure that no other evil artifacts exist. And that should wrap up basically the first step of rendering with the simple glyphs. And I have prepared the shader to deal with multiple glyphs in one rendering pass. So on one square, I should be able to render multiple glyphs. That could be color glyphs rendered on top of each other and glyphs rendered next to each other as a text layout, you know. So later down the line, I will probably have management tools to either just render one square for one character, so you can, you know, I don't know, better animate it, or use it to separate selected text in a text input from the rest. But that's later down the line. I might just have, you know, one square with all of the text that one of the UI node will have, and render it at one pass. It's basically a batch rendering in that case. I will have to look at performance and see if it needs adjustment. But for now, I'm happy with it, and I have also made a little anti-aliasing already, which is not perfect yet, but it's already work in progress. Because if you know how texts are rendered, you know that they are never just outlined, because then you would have like large pixel gaps and the edges would be rather or really jagged. And one of the ideas is to leverage the way the pixels in the screen are laid out. So you have practically 3 rows in most of the displays, and the 3 rows are separated by color. So if you output a certain color, that would, from a distance, seem to be part of the pixel over. So you have practically 3 times the resolution horizontally, which is nice. But if you just do a naive implementation, you would get something like this. As you can see, it's red, yellow, yeah, and blue, depending on where it is. Ignore the fact that the blue is supposed to be on the left, but in this case it's on the opposite side because of how the blending works. If the text would be white and the background a darker color, the pixels would be in the right side. In this case, you can imagine that the blue is actually part of the white area and not the black one. Anyway, this is a really simple 3 segmented anti-aliasing done by rendering the font 3 times, actually in 1 pixel, and then outputting the color. However, again, you will probably not see it, maybe from this distance, that it still leaves a lot of jagged feeling to the font, to the glyph. And it also causes a lot of issues with the color itself. So at this scale, it doesn't really appear to do much. But the smaller and smaller the font, this red and blue, this stark red and blue and yellow and green would offset the color, the perceived color of the glyph. So this is not a good solution. And if we compare it to what Firefox renders, you would get something like this. Of course, the black they are using is different. So I grabbed one that has a slightly different or lighter gray instead of the black. But the idea is the same. And if you look at it more up close, you can see that they are not using pure colors. So it's a nice blend. And I dare say it's like maybe about 10 segments of to the gradient. And here on the blue side as well, it's not a pure blue or a pure red that they are using even for the transition, and it's really detailed, which makes the font really soft and at the same size as what my does actually. So I began to look into this one, and I have a really dumb solution to this, which is close enough, and I will probably keep it for the time being. And that is, yes. So the first step was I have a better version of the previous one. It still has the same colors, but it has a higher resolution. So if I were to zoom in, you would see that now it has a more granular gradient. But this isn't really the best one. So the current one is this one actually. And if you see on the left and the right, this is already much better, even at a distance. Let's say at the same distance as the other one, it's the edge is really smoothed out. It's not as perfect as what Firefox does, because obviously it's they have a much better understanding of how to do all that, and much more time probably to prepare it. But in this case, it is close enough. So of course the color is different, because in my case I just do a 9 rendering basically in 1 pixel horizontally, and I believe that I should be doing some offsetting vertically. But the key point isn't just the number of samplings I do. There is actually a weight to each of the areas. So imagine that we go from left to right in a pixel, and we do that 9 times within the pixel. But since they are still on the same row, you would not have, or I would not have, the anti-aliasing applied to areas that are completely flat, like here, even though they have a little gray area here. Anyway, I will probably add that. But the point is that it's not enough to just add up the first 3 to create a red color, and then the next 3 to create a green color, and then for the blue, the remaining 3, because that would give you the stark colors that you have seen before. So in my case, I added a little weight to the distribution. So for instance, for the red color, the samplings from the left to right, imagine that this 0,1 is the pixel, or well, almost the pixel. It's slightly offset in this graph, but you can imagine it. And the point is that the weight at which I consider for the red is indicated on the y-axis. But you may notice that even the furthest sample, that should be blue is considered for the red color. And for the green channel, it is the same, but it's considering more in the central area and less in the outermost ones. And this gives a nice, I'm not saying it's an even value for each of the pixels in the end, because the green channel is probably a bit less illuminated, but that allows for the red and the blue part to be more dominant in the screen in the very end. But again, it's not really the curve itself that matters, I believe. It's more like that there is a distribution and it's evened out across the pixel. And again, I'm not expecting to render something as nice as what Firefox does. And it's not the aim. I want something to be performant and acceptable to look at. I don't want to see real jagged edges, but if it's a little bit, it's probably not going to be that dominant in a game. Where performance is more important than rendering tiny little text. It's unlikely that a UI in a game would have so little space for rendering text. But again, I do my best and then see if it needs adjustment later on. But this is something that can be done once the rest is there, and then I can see it in context and see how it feels. I even have a picture of how it would look like to render a bunch of small texts. And again, you are probably not seeing it very well, but even with the compression, you should be able to just make out the actual letters. And this was rendered before I fixed the evil artifacts, so some of the glyphs are actually incorrect, and of course they are misaligned because they are just not kerned yet. But you get the idea. This one is I think it's 8 pixel, so it's a text that you would probably not use in a game. It's too tiny for it, but it will be possible, and I aim to have readable text on that scale at least. So that's it for now. Now you know what I'm doing when I'm saying I'm working on text. And I will continue to work on this, update my little shader to actually, get rid of the evil artifacts, add the color glyphs, and then start working on the management of text. I don't really know how that will look like yet, but I imagine it will pan out somehow. Until then, you have fun. Thank you. Ciao, ciao.